Okie dokie peeps, it is 7-1, integration by substitution. This is pretty much the coolest day of your life, so you're welcome. When we go through this, you're going to pick a U. It is called U substitution. Ask me why, I don't know. You're looking for things, the denominator of a fraction, underneath the square root, inside the trait function, the exponent of the x, as you're saying to yourself, oh, all the things that I learned about during chain rule. So we pick a U, we rewrite it as U, in terms of U, if you will, and then we solve a much easier problem and then plug the x back in. I know, I'm excited. Here we go. So we start here looking at this. Whoa, okay, and you can see here's what the original problem was. There was some kind of trig function here, right? And then I had the x cubed, and when I took the derivative, I had the 3x squared was involved, right? That was the chain rule part of it. So you pick that x cubed right there, okay? That's going to be u. So then that makes du 3x squared, okay? Now you're going to rewrite that in terms of u. So when I do that, here we go. When I write the cosine, I got it right. So it's now cos of u, and when I write the du, that takes care of this 3x squared. So by writing the du, I take care of this and this, whoops, dx. And here, I took care of the u. Well, now, that's something I can definitely integrate. The antiderivative of cos is sine, so I write sine u plus c, of course, right? Right. Then we're going to look and say, all right, what is the x cubed? That goes right in there. And I've solved it. So the second one here, now you can see there's an extra t. Using what's in the exponent, that's where I would have had to use chain rule. So u is t squared plus 1. Take the derivative, du is 2t dt. Now, I needed that t squared plus 1, that's why I used it. I need a t. I do not need this 2, so I'm going to divide out by 2. And now I have just the t that I want in the dt. So integral, I'm going to write is going to be e to the u. That takes care of that part right there and the e. When I write du, I'm going to write the 1/2 on the outside so I'm not changing the value. And that takes care of my t and my dx. So antiderivative of e to the u is e to the u plus c. The 1/2 comes along for the ride, of course, right? And then you're going to have 1/2 e to the t squared plus 1, and then big plus c. Now the second row here, I now have some bounds I don't have to deal with, okay? So I'm going to show you how to deal with that excitement. But first, let's deal with just the integral. So my suggestion from before was deal with what's inside, call that your u. That makes du 4x cubed dx. I want the x cubed, that's right there. I don't need the 4, so I'll take 1/4 du. And now I have what I need. So writing my integral, it's now going to be radical u with the 1/4 and the du on the outside. 1/4, make sure I'm not changing the value. The du takes care of the x cubed and the dx. Last thing to look at here now, I have changed. I'm now writing in terms of u. So I have to change these. These bounds were in terms of x. So with that information, plug them in. Here we go. 0 to the 4th, I'll write it over here, plus 5. So that'll be 5. And then 3 to the 4th, 3 times 3 times 3 times 3, 81, right? plus 5 is going to be 86. Now I have a function that's truly in terms of u. So we will remember 586. I'm going to write this as u to the 1/2. Integrating, going up a power, will be u to the 3/2. Over 3/2, I'm going to write times 2/3 times a 4th. And then we're going to plug in the 86 and the 5. And there we go. There's my answer. I know, it's beautiful. All right, example 4. We have a very similar setup that I did over here, no bounds, so that's good. And I would pick what's inside, x to the 5th plus 5. du is going to become 5x to the 4th dx. Now, in situations before, I've gone through and said, okay, I can divide out the constant and it gives me what I want. In this situation, I can't divide out an x to bring it down to x squared. I have to divide out 2. So this is an example where u substitution is not going to work. Yes, there's more tricks coming in the future. All right, looking at the back here, got one more to go. As I look at that, it's harder to replicate 1 plus e to the x, or e to the t over e to the t. So you're going to make u 1 plus e to the t. That makes du e to the t dt. So integral, that's going to be 1 over u du. Plugging in my bounds, e to the 0 is 1. So the bottom is going to become 1 plus 1 is 2. E to the 1 is 1, so this will become 1 plus e. Antiderivative of 1 over u, remember, is natural log. Make sure you have the absolute value bars. All right. And bounds of 1 plus e and 2. So the natural log of 1 plus e minus the natural log of the absolute values of 2. And now there's 2 for you to try. Have a great night.